Hello and welcome to this math placement test review session for CCCC. My name is Dane Peterson. I'm a success coach and math specialist with the College Success Center, and I'm going to guide you through what placement testing is like at CCCC for math courses, different types of math courses here at CCCC, and some sample problems that you might encounter while studying for the math placement test here as well. So let's go ahead and get started. First off, every associate's degree seeking student at CCCC is required to take a curriculum level math course. Okay, that curriculum level math course is going to be determined by your major. So different majors are going to have different math course requirements. Each curriculum level math course is going to have a different developmental math or DMA prerequisite, and we use a placement test to determine which, if any, of those developmental math courses you might need to take. So here's a placement example. To earn an Associate's in Arts degree, that's one of our university transfer degrees, a student must complete one of the following curriculum level math courses, either Math 143, which is a quantitative literacy course, Math 152, which is a statistical methods course, or Math 171, which is a pre-calculus algebra course. Each of those courses has a different developmental math or DMA prerequisite. So for Math 143, that quantitative literacy course, that DMA prerequisite is 10, 20, 30, 40, and 50. So there are 5 different DMAs that you must either show proficiency on with your placement test examination or take if you need them before you could start that math course. 152 has the same prerequisites, DMA 10, 20, 30, 40, and 50. You must either take or show proficiency on the placement test before you can take Math 152. And Math 171 pre-calculus algebra has a little bit of higher prerequisite since it's a higher level math course. That's going to be 10 through 80. So depending on where you would want to transfer with this degree and what program requirements they had, your developmental math courses and your curriculum level math courses might change. So here's the different course content that you're going to find in the different DMA courses. Math 10 is an operations with integer class, the 4 basic operations, addition, subtraction, multiplication, and division with both positive and negative numbers. Math 20, which is fractions and decimals, again those same 4 operations but working with fractions and decimals. 30 is rates, ratios, proportions, percents. 40 is when we start getting into some algebra. We've got expressions, linear qualities and inequalities. DMA 50, we do graphs and equations of lines. 60 is polynomial, many variables, and quadratic equations. 70 is going to be rational expressions or algebra where we have fractional expressions. And then DMA 80 is radical expressions, or when we're dealing with algebra with square roots. Okay, the different class formats. Now, we saw earlier that some classes require 8 different developmental math courses before you could start them. Now, keep in mind, you might not have to take all 8 in order to start that curriculum level math course. You might think, oh my gosh, 8 courses, that's, almost 4 years of math, but no, it's quite the contrary. Each of these DMA courses is only 4 weeks long, so it's not like a traditional 16-week course, and you could take up to 4 of these modules in a given semester. Okay, it's a lab-based learning environment with instructor guidance, and they're graded with grades of either P or R. P means you pass, R means you repeat. And to pass, you must make 80% or higher on the final exam to pass your module and move on to the next one. Each class must be completed successfully before you can move on to the next DMA course in your sequence, but they can be repeated as many times as necessary. Okay, and so you can take any DMA as many times as you would need to before you could move on to the next class. The math courses are a little different. They're traditionally taken as 16-week-long traditional classes, although sometimes we offer 12-week or 8-week sections, graded on an A, B, C, D, or F scale. We adopt a 10-point grading scale here at the college. And any curriculum course at CCCC, not just math courses, can only be repeated twice. So it's important that you get this proper foundational knowledge in the DMA classes so you can be successful in your curriculum level math courses, because you can only take a curriculum level course you can only take it 3 times, repeat it twice. Okay. So the placement test that we accept ours is the NCDAP. That's what we give here at CCCC. It's a free test, and I'll tell you how to schedule an appointment for that later. We also accept SAT scores. Currently, as of November 2014, math scores of 450 or higher exempts a student from math placement. That means you could take any curriculum level entry math course that you would want with a SAT score of 450 or higher in the math section. ACT scores, 18 or higher, would exempt you from math placement. The Compass and Asset are 2 other tests that you may transfer in from other colleges. We accept those as well, but scores vary from test to test. So what to expect when you take the NCDAP? That's the course that the placement test that we administer here at CCCC. This test covers material in DMAs 10 through 60, so the first 6 sections of the 8-section sequence. And you're going to get a score for each of the DMA sections between 0 and 12. Okay, so you'll get a score for DMA 10, a score for DMA 20, 30, and so on. A score of 7 or higher means that you've tested out of that DMA section and you won't have to take that class. But if you score a 6 or below, that means that you probably need to work on that material before you start your curriculum level math, so you'll be required to take that DMA course. Okay. There are 72 questions total on the test, so 12 questions for each of those 6 sections that you'll be tested on. It's an untimed test, so you get to work completely at your own pace, but on average, it's going to take about 2 hours to complete the whole test. You take it on a computer. You're provided with pencils and scratch papers for you to work out problems and the like, but it is going to be a computer-based test. It's multiple choice, so there are 4 answer choices for each question, and you must commit to an answer, select that answer, and submit it before you can move on to the next question. And there's no backtracking on this test. So you must make sure that you have your best choice selected before you move on to your next question, and there's no going back. And this is everyone's big question. Can you use a calculator on the test? Well, the answer is sometimes. Physical calculators aren't allowed in the testing room, so you can't bring your own calculator from home. But sometimes a digital calculator is going to show up on the testing screen. If you see that calculator button, you can press it and use a calculator for that question, but you must close the calculator before you're allowed to move on to the latter part of the test. And just to prepare yourself, when you take the NCDAP, that calculator is going to show up more on the latter part of the test towards the end when they're testing you on more algebraic things than it will at the beginning. When they're testing you on your integer operations and fractions and decimals and things like that, they want to make sure that you can do that by yourself, okay? And they introduce that tool later on in the test when they're testing you more in algebraic concepts. Okay, so be prepared that you'll have to know how to do all your arithmetic, all your fraction decimal operations without a calculator if you want to show proficiency in those first couple of modules. How to prepare? Study. Okay. First of all, you're only allowed to test twice in a 5-year period, so you want to make sure each of your testing attempts count. So make sure you study before you go and take this test. I'm going to show you where you can find some placement test guides on our website, work through some sample problems here at the end of this video. Make sure you attend a placement test review session if you can. If not, this video is a good substitute. We cover a lot of the same information. And last but not least, know your limits. If you need to take all sections of the placement test, the math section and the sentence skills and reading comprehension sections, that could be over 3 hours of testing. And if you think that's going to be too much for you, consider scheduling separate testing dates for the different tests. Take the math one day and the English another day. Otherwise, you're going to be in the testing room for a long time and you might not be doing your best. So before we move on, let's go through a placement example. Michelle is pursuing an Associates of Arts degree here at CCCC, and she said that she wanted to take Math 143 as her curriculum level math course. Okay. She takes the NCDAP here at CCCC, and she receives these scores. She got a 9 in DMA 10, a 6 in DMA 20, a 5 in DMA 30, a 7 in DMA 40, a 4 in DMA 50, and a 3 in DMA 60. So we need to determine which DMA classes she's going to need to take before she can start her curriculum level math course. So keep in mind that she wanted to register for Math 143. That's really important. Okay. Remember, I said if you scored a 7 or higher, you've showed that you have the prerequisite knowledge to pass out of that DMA course, so you won't have to take that class. So in DMA 10, Michelle scored a 9. That's over 7, so she's proficient in that module. She's not going to have to take that class. DMA 20, she scored a 6, so she will have to take DMA 20 based on this placement test. Again, DMA 30, she scored a 5, that's under 7, she's going to have to take 30. Okay. She showed proficiency in DMA 40 because she got a 7. We said 7 or higher was good. Okay. She's going to have to take 50 because that's under a 7. And is she going to have to take 60? Well, we might think yes, because that score is below a 7. But remember a couple slides back when I showed you the prerequisites for Math 143? It only had a prerequisite of 10 through 50. So she's not going to need this math course to test into Math 143, her desired curriculum level math course. So when she registers for classes for next semester, she should make sure she gets scheduled for DMA 20, 30, and 50. And after she completes those successfully, she'll be able to move on to her curriculum level math course. Okay, so once you become a CCCC student, we have plenty of resources available for you to help you be successful in your DMA and curriculum level math classes. We offer free tutoring for any curriculum course that you're enrolled in at CCCC. So it's typically students who have been through the class before. They've been very successful in it and been recommended by their instructor to tutor for that class. We have online tutoring through companies such as Smart Thinking and, I forgot to write this down on my slide, Upswing. That's our other online tutoring partner. Okay. We have these great placement test review sessions and math coaches such as myself who can help you get more individualized support while you're working through your math curriculum. Now I'm going to show you how to locate the study guides that will help you prepare for the math placement test. First, go to cccc.edu/student-services/placement testing, and then over on the right, select the link to study guides. Once that screen loads, in the center, at the very top, you'll see a link for the NCDAP Mathematics Sample Question Guide. Click that and it'll open up a PDF made by AccuPlacer with sample questions for all sections of DMA from 10 through 80. Now keep in mind that the test you'll be taking only covers the first 6 sections of DMA, so the last 2 sections on rational expressions and radical expressions and equations, you're not going to be tested on those, so you can omit those from your studying, but make sure that you do as much as you can from the first 6 sections of that study guide as possible. Okay, so before we get started into sample problems, let's talk about some helpful formulas that we might need to have memorized to help us be successful in this test. And we're going to start with some geometry problems, some geometry formulas. So the important ones, we're going to start with squares. Okay. So for squares, with side length S, okay, all sides are the same. The area for the square, or the amount of space that it takes up, is going to be the side length squared. Okay. And the perimeter for the square is going to be, there's 1, 2, 3, 4 sides on the square, so it's going to be 4 times the side length. So remember, the perimeter, or the distance around an object, for the square is going to be 4s. Okay. Next, let's look at rectangles. Okay. Rectangles, we're typically going to label the sides of a rectangle with a length and a width. Okay. The area for a rectangle is going to be length times width. Okay. And the perimeter, we could just add up all the sides, but algebraically we would call this 2 lengths plus 2 widths. Okay. Triangles. Okay. Let's talk about different types of triangles. The important formula that we're going to start with for triangles is the area of a triangle, which I'm going to write two ways. We might say base times height divided by 2. Okay. Or you might have also seen that as 1/2 times the base times the height. But height can be taken from many different places in a triangle. If we had a triangle like this, where we labeled this side at the bottom the base, the height of a triangle is the distance from the base to the opposite point that makes a right angle with the base of the triangle. So in this particular case, we measure the height on the inside of a triangle. Okay, but we can take the height from many different places from a triangle. We have an obtuse triangle like this, might have the base here. The line that's going to go from this opposite tip and make a 90-degree angle with our base is actually going to be outside the triangle. Okay, so this over here would be our height. We can even have a right triangle, okay, where you have a 90-degree angle here in the side. Okay, so if this is the base, the height of this triangle would actually be in the opposite side, or the adjacent side, to the base. Okay, so we can take heights from many different places. The other important things with a triangle, if you want to find a perimeter, you would just add up all the sides. So we might call this A, B, and C. So the perimeter here would be A plus B plus C. Okay, and this is also a really important formula with the for right triangles. This is called the Pythagorean theorem, and we use this to find side lengths of right triangles. And the Pythagorean theorem states that a squared plus b squared is going to equal the side lengths of the hypotenuse c squared. Okay, you may have seen this like this as well. C equals the square root of a squared plus b squared. Okay. And remember, we use the Pythagorean theorem for finding unknown sides of a right triangle. Alright, so continuing on with our important formulas, the last shape that we're going to talk about is circles. Okay. Okay, so let me see if I can draw a nice fancy circle here. Okay. So let's look at this circle here. Okay. The point in the center, we usually call C for center. Okay. Okay. This distance from the center to the outside of a circle, okay, is called the radius of a circle. Okay. If we went through the center, side to side, okay, that's a diameter. We use D to represent that. And we can find a formula for the relationship between these two. We can say that the diameter equals 2 radiuses, right? Because there's a radius here on this side, okay? There's a radius here on this side. So we can say the diameter is 2 radiuses. We could also say that the radius is half the diameter, or the diameter divided by 2. Okay. And we're going to need to know the radius of circles for our two formulas that we're going to be using here today. The area of a circle is pi r squared. Okay, and the circumference, which is kind of like the perimeter, is the distance around a circle. Okay, is 2 times pi times r. Now pi is a variable that we use to represent a known quantity of the for circles. It's a never-ending decimal, but we usually approximate this to be 3.14 when we're doing pretty easy estimates for circles. That number does continue on for quite a ways, infinitely actually, but for our purposes for this test, we're going to use 3.14 to approximate for pi. Okay. It's also worth noting, you may stumble across some problems through this review, that the number of degrees in a circle is going to be 360 degrees total. Okay, that's when we talk about angle measurements of a circle. So if we're going to measure an angle in this circle, we'd measure it in degrees, like this angle right here. Okay, they're 360 degrees total in a circle. Okay, so the last formula that we're going to talk about today is the quadratic formula. Okay. And this is for quadratic equations. Quadratic means we have an x squared, or a variable squared in there, of the form ax squared plus bx plus c equals 0. Now, in this formula, our variable is x, okay? And a, b, and c are all constant. So when we were to apply this formula, we'd have numbers for a, b, and c. Okay, and the quadratic formula to solve for x for equations of this type, one of the methods that we can use is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Alright, so that's to solve quadratic equations of the type a squared plus b squared, or plus bx plus c equals 0. Okay. Now, if you've never seen this before, that's quite alright. The only section that you would see this formula in would be in DMA 60, and odds are, or for many math classes, that's not even a prerequisite. So don't feel like you need to know this to take this placement test assessment or be successful at math at CCCC. Okay. That's why we give you this test, to figure out what you know and what you don't, and we make sure we get you put in the right classes. So if you've never seen any of this stuff before, and as we move on, that's okay. That's why we're here, and that's why we're in school. So let's jump into some sample problems. Okay, so this is the first problem I pulled from the NCDAP review. Okay, it says the sum of Cheryl's scores on the first 4 quizzes in her history class was 364 points. If she scores 96 points on her next quiz, what will her average score for the 5 quizzes be? Okay, great. So first of all, what is an average? An average, okay, you may have heard this as an average or a mean, is the sum divided by the number of items that you have. Okay. Alright. So if we want to find the average of Cheryl's quiz score here, okay, first we need to add all the points together from all her quizzes. That's the sum of her quiz grades. They gave us part of that sum, right? It's going to be 364. Okay. Plus her next quiz, that's 96, divided by the number of quizzes she had. Well, how many quizzes did she have? They tell us that she had 4 quizzes, right? And then on her next quiz, so that's 1 more. So together we had 5 quizzes altogether. Okay. We're going to start by adding up the numbers on the top there. If we add 360 plus 96, we're going to get 460. Okay, and we do 460 up to the side here, divided by 5. 5 doesn't go into 4, but it'll go into 46 9 times. That's 45. We subtract and get 1. Bring down that 0. Okay, and then 5 will go into 10 twice. We subtract and get 0. That's good. So her average for this quiz grades is going to be 92 points. Letter C. A large dining room table is in the shape of a semicircle of diameter 12 feet as shown above. Of the following, which is the closest to the area of the table, and here they told us that pi is going to be 3.14 for this question. Okay, so what are the key words in this word problem here? Well, first we know that this is an area, okay, so we need to find area. What's the formula for that again? For a circle, area equals pi times r squared, okay, and they give us the diameter of 12 feet, okay, we don't, that's good. Let's extend the circle here. The diameter is 12 feet, but we want the radius for our equation over here. So what are we going to have to do? We're going to have to cut this diameter in half. So our radius is going to be 6 feet. Okay. And also notice that we're not going to consider this half of the table over here. Okay. So we're going to need to cut this total area in half. Okay. How are we going to do that? Well, we could cut it in half by dividing the area by 2. Okay, so if I cut that side by 2, I would have to cut this side in half as well. Okay, so let's start plugging in some numbers. So pi in our equation we're going to use is 3.14. Okay, times the radius, which is 6 squared, still divided by 2. Okay, I'm going to start by doing our exponents over here. Okay, 6 squared is going to be 36. So I get 3.14 times 36 divided by 2. Okay. Now, I have two options here. I could do the 3.14 times 36. That's going to give me a decimal answer. Okay. And then I could divide that decimal answer by 2. But call me crazy, I like to avoid decimal division if I can. So I'm going to do my division with my whole numbers first before I do any multiplication. Since I have a common factor between the top and bottom of this fraction, I can simplify it out now. My common factor is between the 2 and the 36 here. They both have a common factor of 2, so I'm going to divide that out. 36 divided by 2 is going to be 18. Okay. Then 2 divided by 2 is going to be 1. Okay, so my new formula is just going to be 3.14 times 18. Okay, I don't have to write over 1 because anything divided by 1 is just itself. Okay, so now I only have one step that involves operations with decimals, and I'm going to do that out to the side here. This is when we divide with decimals, we line multiply with decimals, we line everything up on the right. Oops. Okay. Decimal placement is going to be last. We start by multiplying everything by the 8. Okay. Put in our 0 placeholder. Then multiply everything by the 1. Okay. Now we have to place our decimal. Okay, we count how many spaces from the right we have decimals in the original problem, which is 1, 2, and we move in that many places here in our answer. So we get an answer of 56.52. Okay, if we look at our choices, if we were to round this, we would select B, 57 feet squared. Okay. Our third sample problem. During a basketball practice, 2 players, Sidel and Jaron, each attempted 52 free throws. Sidel made 40% of his free throw attempts, where Jaron made 52% of them. How many more free throws did Jaron make than Sidel? Okay, so let's attack this guy. First we have Jaron, okay, and he made 52% of his free throws, which was 25, so 52% of 25. Okay. Now, to change this into a good mathematical expression, we're going to have to change some things around. Okay. First, we want to express 52% as a decimal. To do that, we're going to have to move the decimal over 2 places to the left. Now, you might be saying, well, there's no decimal within 52. Well, when we have whole numbers, we imagine it to be here to the right. Okay, we're going to move that in 2 spaces to go from percent to decimal. So now we have 0.52 of, when we're dealing with percents, means times, okay, 25. Okay, so 52% of 25 is going to look like 0.52 times 25. Okay, let's figure that out. I'm going to go down here, 0.52 times 25. Start multiplying by the 5. Add that 0 placeholder, and then multiply by the 2. Okay, and then we're going to add these up. When we move in our decimal 2 places, we move it in down here. So we get 13.00 or 13. That's how many Duran made. Okay, next let's look at Sidel. He made 40% of his, the same number, 25. So that's going to be 0.40 times 25. Okay. When we do that multiplication, placeholder, then 2 times 0 is 0, 2 times 4 is 8. One 2 spaces in, 1 2 spaces in down here. Okay. He made 10. But remember, the question asked how many more free throws did Duran make than Sidel? To do that, we're going to find the difference of these two, 13 minus 10, or 3. So A over here is going to be our correct answer. All right. Now we're going to start getting into some algebra. Okay. So in this problem, we're going to solve for the variable x. We're given the problem x over 3 minus 2 equals 5x minus 2. Okay. So here's how I like to attack problems like this. I like to move all the variables to one side and all the constants to another side. Okay. Good. I'm going to start by moving this 2 here over to this side with the other 2 here. And to move these things from side to side, I have to perform the opposite operation. I'm subtracting 2 over here on the left, so I need to add 2 to cancel it out. Negative 2 plus 2 is going to be 0. Okay, so that cancels it out. And I'm going to add 2 to the other side over here. Well, in this case, it just so happens that what? Negative 2 plus 2 equals 0. All my constants cancel out. So I've got x over 3 equals 5x. Great. Okay. So let's continue working. I want to get rid of fractions, right? I don't like fractions. So to get rid of this 3 on the bottom, I could multiply by 3's reciprocal. Or if we imagine this as 1 over 3, the reciprocal of that is going to be 3 over 1. I have to do the same thing on the other side. Okay, the 3 divided by 3 is going to cancel out, so I'm left with 1x times, when I multiply these two together, 15x. Okay. What's going on here? I have x equals 15x. How can a number equal a number times 15? Well, there is one way to do that. There's only one way to do that. That would be if x were to equal what? 0. Okay, so B here is going to be the correct answer, because the only way for this sentence to be true is if I plugged in a 0 for x, and then 15 times 0, because anything times 0 is going to be 0. So the only way to get a true statement there is for x to be 0. Sample problem number 5. Which of the following is true about the line graphed in the xy plane here? Okay, so we've got a plane here. Over here, this is the x-axis. Then we've got the y-axis going down. Okay, and they want us to describe some things about this line that's going, that's on this plane. They want us to tell us what the slope is, okay, and the y-intercept. Okay, so first let's talk about slope. Slope, one way to define that is rise over run. Rise means how far we go up, and then run means how far we go across when we go from point to point on a line. So let's determine some points on this line. We want to pick nice points that intersect at these little crosshatches here. So this point right here is a good one. It intersects at -3 and 0. And then this is a good one here. We got 0 and 2. Okay. So let's find the slope of this line. The rise is how far we're going to have to travel up to go from point to point. And so we're going to have to go up 1, 2 spaces here. Okay. So rise is 2. And that's going to be a positive 2 since we went up. Okay. And then the run is how many spaces we go over to get from point to point. And if we count our blocks, 1, 2, 3, we've got a run of 3. So our slope for this line is going to be 2/3. Okay. So we've automatically canceled out these answers because the slope's wrong. Okay. The y-intercept means, what does intercept mean? Intercept means crosses. So the y-intercept is where we intercept this y-axis here. And that's going to be this point here. I covered it up a little bit when I was writing earlier, but that's going to be at the point 2. So our correct answer here is going to be B. We have a slope of 2/3 and it intercepts the y-axis at 2. This is going to be our last sample problem, and this is, we talked about this earlier with formulas, a quadratic formula. Now we could use that fancy-dancy quadratic formula that we saw earlier, but I'm going to show you how to solve this problem by factoring. So we have the quadratic x squared minus 3x minus 18 equals 0. Okay. I want to factor this so that I have two quantities, which when I multiply them together, they're going to give me this equation back up here. Okay. I like to think of this as like a fill-in-the-blank problem. I've got 1, 2, 3, 4 blanks to fill in. These first two blanks should give me the x squared term. Okay, and the only way to get x squared by multiplying is going to be x times x. X times x will be x squared. So that'll work here. These back two blanks, here and here, should give me the 18. There's a lot of different ways to get 18, though. There's 1 times 18. There's 2 times 9. There's 3 times 6. I think that's an exhaustive list of all the different ways to get 18 with multiplication. So which one do I choose? Well, the sum of these two is going to give me the 3x in the middle. So those should add to 3x, or excuse me, negative 3x, because that was a minus sign. Let's not forget that this is a negative 18 and negative 3x. Good. Okay. So I need something that's going to multiply to negative 18, okay, but add to negative 3x when I take these sums here. So let's kind of do some guessing and see what works. If I put 1 and 18 in there, this is going to give me 1x, and this is going to give me 18x. Okay, and no matter which way you shake it, that's never going to add or subtract to negative 3. They're just too far apart. So we know that that's going to be incorrect. So let's try something else instead. Okay, what about if we tried 2 and 9? Okay, that's going to give me 2x, and that's going to give me 9x, okay? 2x plus 9x is going to give me 11x. 9x minus 2 is going to give 7x, so there's really no way to combine those either to to give me the negative 3 that I want. Okay, so by process of elimination, I know that I'm going to need the 3 and the 6 left over here. This multiplies to 3x, this multiplies to 6x, okay? And if the difference of those two is going to be 3, that's the number I want, but it's not the sign that I want. Okay, I want a negative 3x. So to get that proper sum, I would make this 6 negative. I would have a negative 6x, a negative 6x, and a plus 3x, because plus 3 minus 6 gives me negative 3. Good. Okay, so that means that this 6 had to be a negative 6 to give me the product of negative 6x, and this 3 had to be a plus 3 to give me the product of positive 3x, and then the sum that I wanted. Okay. Use the FOIL method to FOIL this back out. You would get that that original problem back. So I'm going to rewrite this just so it's a little neater. Okay. And let's talk about what's going on here. Here I have a number times another number. Okay. And the only way to get 0, because remember that's our answer over here, is 0, through multiplication is if either this term was 0, because 0 times whatever this is would be 0, or if this term would be 0, because 0 times whatever this would give me 0 as well. So to continue to solve this, I just set both of these equal to 0. X plus 3 equals 0 would give me a true statement, because that whole term would be 0, and x minus 6 equals 0 would give me a true statement as well, because that term would be 0. Okay, and then I just solve each of these individually, because this is going to give me 2 answers. I'm going to subtract 3 on both sides on this side, because positive 3 minus 3 cancels out, and I get x equals negative 3 over here, and then add 6 to both sides over here. Okay, those cancel out, and I'm left with x equals 6. Okay, so those are the 2 answers to this quadratic. But remember this question said, which is a possible value for x? Well, it's going to be this right here, the c equals 6. All right, so that's going to finish. I wanted to give you some information about how to schedule appointments for a placement test. We have them on all 3 of our main campuses in each of our 3 different service counties. In the Lee County campus, call this number over here for our admissions office, 919-718-7300. In Chatham County, in the Pittsboro main campus, you can call the Academic Assistance Center at 919-545-8029. And in Harnett County, at our Lillington main campus on 421, you can reach Student Services at 910-814-8863 to schedule your appointment there. Now, before you schedule, make sure that you allow yourself enough time to study adequately before you take the test, so you're nice and prepared. And remember what I said earlier. If you do need to take all parts of our placement test, you might consider making 2 separate appointments and split your testing up between 2 different days so you don't get overloaded. Okay? All right, folks. That's all I have for you today. I want to wish you luck on your placement test. I also want to thank you for choosing CCCC. If you have any questions and you want to contact the College Success Center for questions about placement testing or math nerds like me, or anything else you might need college-wide, you can call us at 919-718-7485. Thanks for watching, and again, good luck on your test.